since the CLAN circuit is designed to open under EXE condition, and so but later will uh, and it can let the CLAN circuit open in operation normal operation. So so it will cause the permanent leach current, and which may lead to circuit burnout.
Thank you. I think due to the time constraints, so I had to stop this Q&A session. Thank you for your presentation. And then let's welcome the next presenter, Sun Guan.
Good morning, everyone. My name is Guan Bing Chen. My advisor is Chen Jianxu, and my presentation topic is Power Error Robot Navigation System based on deep reinforcement with prediction Gemini Pitfall. And this is my outline. First, I will introduce the background of AMR navigation and the relation work and power robot navigation, then the system of power delivery. Finally is our efforts, experiments, and conclusion. As robot and artificial intelligence technology continues to advance, there is growth interest in the development of automatic mobile robots AMR. These robots offer high flexible and versatile automatic computation that are well suitable to market demand. This a wide range of applications in automatic buckets. And deep reverse learning is a promising aspect that uses deep learning network to automate learn layer protection allows it to effective taking high demarcation powers and heavily log automate for input information. This has led to significant improvement in the performance of traditional reverse learning, particularly in the field of navigation. And navigation system based on deep reverse learning has been applied in various sensors such as local automation, indoor navigation, multi-robot navigation, and social mode navigation. And follow are the expression of social mode navigation and its video. You can see you can see that the robot navigation in the cloud environment. And now I will tell about relation work traditional method. The traditional method is a related method, and it includes RVO, represent vector offset, and OCA. In the deep learning programming to find conclusion-free voltage by introducing middle pairs. And social force model, antennas attracted and repulsed force to model interaction between the robot and other agents in tower. These algorithms consider local interaction and neighbor information to generate conclusion-free translation. But there are some limits with traditional method. In creation method, they may cause robot environment to be unnatural, short-sighted, unsafe, and various robot power. And in learning method, CADIO and SACADIO and LSTMIO has been organized to achieve powered error navigation in social model navigation research. but the above method cannot address complex human-robot interaction behavior. To save this problem, SAIO was replaced. SAIO used information learning for training and the orchestrated for model installation. Additionally, it featured a social attention pooling model that instructs population behavior for power in a deep reverse learning framework. And the following are the contributions of SAIO. First is rethink humans-robot pervasive interaction with a self-attention method. Third is generate models humans-robot as well as human-to-human interaction in the reverse learning framework. And the picture is well attributed of SAIO. Robots in powered environment need to navigation, safety, and infection will achieve multiple goals, which may compete with each other. To achieve model object effect, previous certain material that method set of reward functions can be designed and comparing into a single objection if these goals are independent of each reward. The number 10 of the reverse paper purports an interaction model properly control forward to predict human interaction and their interaction. Also design multiple object functions to optimize the robot interaction. This picture shows that the object extrapolations for the robot in this paper. According to the above method, we use several reward functions to enable the robot to navigation safety and effectively encounter environment which considers auto goals such as time limits, pace moving, and compute advices. Before introducing our effort, this section is problem formulation. For robot to navigation in powered environment, we ensure that the robot can perceive the state information for human and robot itself from sensor, and the state vector for each human and the state vector of the robot itself are designed as following. Each agent, robot or human, can observe each other's position, voltage, and reduce which the unstable state, and propose vectors and the distance between the robot and the target point. Finally, the state of the robot and the state of each human are combined together with name showing the vectors of robot speeding near was described for 5 speed in the edge vectors was described to 8 observations even between 0 to 2 pi. In title, there are 41 demonstration action speed, 40 dispersion action, and saturation. In the former work for reinforcement learning, the robot navigation test is regarded as a simulation decision-making problem. We use free learning as our learning method, like the purpose for remote learning to find the observation policy, which is to making the exceed title's reward. Where is the reward received at each time? Gamma is the discarded pictures between 0 and 1. It's the operation goal function that estimates the express return, and is the state transfer properly from time to time. And then we use TE method and express reply machines to train the variable network. The update of the variable function is correction in the extraction to TD error. And then reward function, so we want to make a robot smarter observation effect. We design metal reward function related to save time effective conclusion of events and plan to move it. And this is our effort, and we propose PMOD-SARL, a prediction multiple object covered reward navigation system based on deep reinforcement technology such as SARL. The system is designed to above multiple objects including navigation safety, time information, conclusion avoided, and path smoothing. The rail network can be divided into 4 parts. First is prediction model. The second is interaction expression model. And third is double selection attention model. And the third is Asian planning model. And prediction model tremendous a high success rate in navigation and reduce the likelihood for conclusions in complex environments. We have developed a prediction model. This model is designed to precision predict the democracy interaction between humans and human to robot. Our prediction model employs an extra based on long short-term memory LSTM network, which are networks simply designed for proposed and predictions time-series data. The key observation of LSTM is its ability to learn long time span. This ensures the timeliness and accuracy for navigation decrease. During the train part, the model learns from a complex set of human feature vectors, including position vectors and interaction parameters. These features are complete for the models, and they contain not only the correct set of each environment, but also the interactions between individuals over the models to predict behavior and path choosing in various systems. To evaluate the interaction between human and robot during power navigation, it is necessary to consider the input of each human on the robot, as well as the input of human on each other. We organize 2 stacks of NLP to propose the complex human state information unchanged from sensor. In this picture, when human passed by the robot receives the state through the first NLP learner to obtain fixed learning picture. And the outside is taken as the input of the second NLP. Finally, the interaction features SI between the robot and each human can be obtained. Double selection attention model. In order to propose information effectively vary the number of human change, it is necessary to construct a model that can handle any numbers of humans. In order to estimate the interaction for each human's attention on the robot, we use attention includes machine to get the attention source of each human, so that the robot can know the humans who have the greatest influence on it. Through the attention source, we use the double selection part to select the attention source. That have these inputs on the robot. The following features and the formulations were attributed for double selection attention model. Both linears are similar. We use the first 2 impressions to correct attention source, and then calculate means and sensitive error as our selection machine. Finally, through source and average, we can get the cover picture. After obtaining the picture case from the double select attention model, it is expressed to use the attention planning model to obtain this instrument value. Here's MD is a NLP with value assertion function, and V is weight. Finally, through the deep reinforcement method, value can be optimized to obtain the robot navigation stage. And in our environment, all humans are controlled by ERBO, and the number of humans is varied to increase the context for the environment. The early simulation environment is approached from night, which is created by OpenAI Gym. As shown in figure 8, the blue concerts are humans, green is robots, red star is gold, and orange one is a tree turning red, which can let the agents can replace when facing dangerous. The following training resource based on the OCAD and ERBO method. Figure 8 shows that the over conclusion rate based on ERBO method will decrease. And figure B shows that the average navigation time to reach the target point will increase due to safe constellation. Also, we use unfinished combination for robots which can be reduced models of different. And the complaints baseline with our method are based on ERBO, CADIO, LSTMIO, and OMSAIO to environment where prediction part add to the navigation success rate. We remove the complex code NODSAIO as an additional model. And we use five methods to environment the above method. First is success rate and conclusion rate, timeout rate, and navigation time and navigation distance. And is the resource table, we reverse to our metrical reward function to each baseline and use a star to report them. You can see that our method has the best performance in overall metric. Although the ERBO and CADIO is feel better than our method in navigation time or distance, but it's safely and graded and has the highly conclusion rate. Compared to a traditional method, as the number of humans increased, the success rate of ERBO greatly decreased, where the conclusion rate and timeout rate gradually improved. In the left picture, this finding suggests that the traditional method experienced a frequent robust number in district covered environment. In PMO-DSAR, the robot can reach the goal effectively and safety and try to keep strike. As shown in slide figure, it ensures and also in the environment with 5, 10, and 50 people, the PMO-DSAR almost outperforms the ERBO in all 5 measures in table 1. In figure lab 2 in the and PMO-DSAR outperforms CADIO by 49.4 in success rate and had 48 low conclusion rate, which show that the robot is better able to reach the target point with major safety. In addition to LSTMIO, OMSAIO, and NODSAIO will experience delay at the ring of reverberation. And in the environment with 10 people, we can see that PMO-DSAR operate remote and NODSAR is in both navigation time and distance. In contrast, in the environment with 50 people, the navigation time decreased by 3.55 seconds, but the navigation distance increased by 0.8. And our proposed method can run to metric rewards, consider safety, time infection, conclusion advice, and can smooth run abstract from robust navigation. And this is my conclusion, and Virtual, we propose a mature object prediction covered robot navigation system based on a deep reinforcement learning system. Our contribution will create a social attention information learning aspect that use prediction models to select safety and more infection pain will also consider safety, time infection, conclusion, avoid, and pain smooth to learn how to navigation. Achieve goals with navigation. Experiment results show that as the number of people in the environment increase, our proposed PMOD SAL has highly performance at results than prevent students in terms of success rate, conclusion rate, and handout rate. And this is my reference. Thank you for listening.
Any questions from the floor? I wanna ask, why you use the LSTM for the prediction model rather than use the RNN model?
Because students can save the mission gradient problem of RNN well, living with long time deployments which make it more infection in contract long term problem in time square. So we choose LSTM.
Why does the predictive model only predict the next step size instead of predicting multiple steps?
Because single step focus allows us to integrate the logic information in real time, which can provide more action in a complex and recurrent change environment.
Any other questions? Okay, so if no question, I have one more question for you. I realize you use MLP to analyze the human state, right? Complex human state. And then in your architecture, you use two layer of MLP. May I know why? Have you ever conduct the evaluation test? I mean, you may choose 2 or 3 or 4. Why you only test the 2 NLP layers? 这么快？因为这个就是我们是用别的体系，所以它一开始就有问题。
Because we use in GitHub somebody method, so we didn't have to arrange this part.
Okay. Okay. Okay, I have no question. Thank you for the presentation. And then let's welcome the next presenter, Li Changyu.
My name is Li Changyu and my professor is Yang Wei, and then my topic is the enhanced solution diversity in a dramatic problem using a Python AI model. And today, this is my outline. First, I will introduce the research motivation and objective. And following a result study, then I will discuss the fine-tune method proposed for this test. And chapter 4 will dive into the solution of the research experiment, and finally we will conclude and remark and talk about the future work. With the rapid, first with the surge of the online learning platform Precision pandemic, the numbers of the user has been steadily increased, leading to the widespread adoption of the e-learning. I believe everyone has used the online education platform, which include number of practice exercise and a video lecture recorded by the teachers. And however, this results often requires a significant amount of manpower to prepare, such as teachers need to spend time to record the videos. This result in slow data updating rate and reduce the flexibility. And with the rapid advantage of the artificial intelligence, many education platforms has begun utilizing large language model as a foundation for education. However, their applications are primarily in the large language and programming fields, like Santa is for the colleagues test preparation. And however, there are few applications in the fields in the mathematics. Therefore, the study focuses on the fine-tune a large language model to generate multiple problem-solving methods for the mathematics. And this is the simplest framework about the large language model. And above the basic structure can split into the processing and the main components. And because the large language model is too big, so I will focus on the main section in this work. And the first thing is about the tokenization. Tokenization is the first step where when the users input the sentence mainly to segment them into smaller units, and we call those units tokens. And the tokens is the basic unit in the NLP field. And you can see there are two examples below, and one is English and other is Chinese. And we can see the tokenization in English doesn't have any surprise. You just find out the space and find out the punch mark to split it. And while in the Chinese, there are two different outputs, which is caused by the different models for segmentation. Is because the different model to segment it. So in Chinese, segmentation issue is very common, and also in the mathematics segmentation. And the picture at the right side illustrates the transformer architecture. Is include the equal layer and equal layer. And in NLP field, we are focused on the encoding method. First is the absolute position embedding. Second is relative position embedding, and third is rotatory position embedding. Since NLP involves sequence-to-sequence position encoding is crucial. Relative position embedding and rotatory position embedding has more common encoding method in NLP, and they emphasize the relationship between tokens and tokens. And currently, there are various large language models on And the basic difference between the large language model is their inner structure. The large language model doesn't necessarily to follow the encoder and decoder structure, but can use the parallel randomly, and different pairing method is suited for the different scenario. For our task, as you can see, the decoder only structure is suited for the text generation, and equally only is suited for the classification and parser answering. If you use the encoder and decoder layers, it's very good to translation the languages and summarizing. And in our section, we choose using the decoder only texture because we want to generate the answer from the questions. And so with the rise of the large language model, there are many people to become the adherents to deal with the challenges with the model based in the mathematical calculation text. Among them, the GOAT model. The GOAT model is performing better in the address accuracy issue in the calculation, and you can below is the example. The instructor is an input and output is the result. Upon close observation, we found that the address accuracy issue, they trying to use the basis calculation method to teach the model specific problem solving technique, and it also can deal with this calculation problem. And but our we are aiming to develop software for the education. So we think the basis calculation step is not very good for education. So we're trying to use in other ways to solve this question. We want to integrate a CS system to our section. And the mathematical calculation has been a significant challenge in LP field, unlike the language like Chinese or English and so on, which is those language also has a limited vocabulary, but numbers are infinite. So how can we express the infinite number with the finite digits? It has become a really big problem. And in this situation, in this slide, I want to talk about the molecules. And as we talked about before, we choosing the decoder only layers for the main structure, and we can see the GPT and Llama is the only decoder layers, and another reason we choose the Llama is because the tokenization, and because we can see the GPT tokenization is totally different with the Llama's tokenization, and you can see the GPT tokenize the numbers will tune up 2 digits or 3 digits, and we think that is not a good thing for our calculation. And in our test, we choose a Llama for our basic model, and we use the supervised fine-tuning for the basic method, and we propose the 3 dataset design ways. And previous study has the first thing is the function design, and the previous study has found the large language model has learned capability for addition and subtraction, while application and division require special learning method like the COT and as mentioned earlier and the GOAT. In our study, we focus on now the calculation correct answer. We are focused on the learning step, the solving step. Yeah, we'll focus on the calculation step. Therefore, we treat the multiplication and division by using a special symbols. Those symbols allow the model to decide when they need to use the function or for calculation, and they're calculating answer through the CS system, and this way can reduce the calculations error, and this approach does not reduce the calculation error but increase the diversity of the training data. And below this, the model's output, as you can see, the model can use the functions for calculation, and they also can transform the numbers to the other numbers. And the second is the memory processing. As we know, the output of the language model is iterative continuously and with each character generates, and also an already generated output is also be considered. However, due to the position encoding, the influence of the data set will become more smaller, and therefore we organize the positions of the questions and answering to bring the close together. And this is the transforms type, and you can see the question is more closer with the output and the answer. And the third part is order. And as we mentioned earlier, the positional relationship of the text is crucial for the model's inferences. However, unlike text, each number does not have the fixed order. Therefore, we aim to provide more reference points. And below is the example where you can see that the order of the answer basically corresponds to the calculation process from the left to right. So it can give the model more references to by what is the next digits for this question. And this is our experiment result. And the red our matrix is using average accuracy. The n is the total number of example, and we use the 1,000 example for this 1,000 of questions to do this average accuracy. The accuracy, because one question we can generate multiple answers, so each question will have each accuracy. And let's see, you can see that the blue line is the original of data set, is no other method, and orange line will add in the function method. The green line added more memory function, and the red line has the three methods together. And we can see the red line present the result that has three methods are used, which perform better and more suitable compared with the scenario, because we have 1,000 of questions for this matrix for this experiment. However, we can see that when we add in function and we add in the function, then we will find the function as a function is not improve the average accuracy a lot. This is because that the multiplication and the divisions problem is with a large number in the model, the model chance to calculate through the decomposition. So we can see the in the output only have one thing use the functions, and the right hand side the memory method shows that the memories really can improve the average accuracy. And the third, and we adding the order. And before adding order, we can see that average accuracy is very unstable, and because the data is not ordered, and the model is hard to learn the every digit or every number, how to decompose it, or how to add it, or how to subsection. And as we order the output, and we can find the average accuracy is get higher, and it get more stable. And in this study, we fine tune mathematical problem solving models that enhance the diversity in automatic math text, achieve increase approximate 8% in average accuracy through the data set design. The study demonstrates the potential of the large model in mathematical education tasks. And in the future, maybe we can utilize the tree of thought to create a personal math teacher. And in this task, we show the the model's ability to the mathematical task. So in the next step, we can add more personality into this section. This is my reference, and this is my presentation. Thank you.
Thank you for your presentation. I would like to open the floor to the questions.
Did you compare the performance between Llama and GPT?
And actually, I didn't do this comparison because the previous study has shown that the tokenization in the Llama has a greater performance in the arithmetic text. Thank you.
Can you tell why the average accuracy will become stable when adding the order?
Okay, this is our guess is because that the the large language model will focus on the position and the orders for each digit or each numbers. So if we give the order, it will reduce the complexity of this task.
What kind of precision encoding you use in this research?
In this research, in large language model, the relative position embedding and rotary position embedding is common in the large language model, and I choose use the rotary position embedding because it use the absolute position to show the relationship between the tokens.
Thank you for your presentation. Due to the time constraint, let's welcome the last presenter. I think should be the Lutfi Afiza.
Yuda, and my advisor is J.P. Lopez, and my research is a novel cooperative deep reinforcement learning to learn how to communicate in multi-agent cooperative class. And this is the outline. And then deep reinforcement learning, or DRL, stands as one of the most significant advancements in artificial intelligence, mastering fast from board games to complex simulation. But what happens when we move from single agent to multiple agent? This introduces us to multi-agent reinforcement learning, or MRL, where the game changes completely. The agent must not only understand the environment, but also each other, which brings us to the crux of MRL biggest challenge, which is effective communication and coordination among agents to achieve shared goals. In the natural world, effective communication is key to survival and success, and the same holds for true artificial intelligence. MRL allow us to explore complex interactions akin to social behaviors observed in humans and animals. Despite its potential, we are confronted with significant hurdles, such as scalability issue and communication bottleneck. Previous efforts like IPPO and NAPPO have advanced the field, yet they fall short achieving the seamless coordination we aspire to. IPPO adapts the proximal policy optimization for multi-agent settings by allowing each agent to learn independently. This method simplifies scaling and complex environment as each agent optimizes its own policy, viewing other agents as part of the environment. However, this independence can lead to suboptimal strategy for tasks that require coordinated efforts as agents do not directly communicate or develop joint strategy. As we can see the architecture in here in training part, each agent has their own critic, and in execution they do from their own policy. So they learn from what they observe independently without knowing the other part. MAPPO, or centralized training. MAPPO extends IPPO by introducing a centralized critic that evaluates joint step action value, guiding agents towards a unified strategy. This centralized insight improves coordination and collective outcome, crucial for tasks requiring the tight collaboration despite its advantage. MAPPO has computational complexity and introduces potential risks with its centralized component, which could lead to vulnerability if compromised. MAPPO added the CTDE, which is centralized training and decentralized execution, which means while in training it has a centralized critic, which means that all agents see the same thing or get information as one. While in execution, they run their own policy. Okay. This is the environment setup that can be used. In this section, we explore the simulated environment and the task design to test the cooperative strategy of two agents working together to manipulate an 80 kg box. Our environment is a simulation that tests agent interaction in three distinct scenarios. First, the target location only scenario focuses on moving the box to a predetermined location, and the second, the target location only, which means only considering the orientation of the box, and the third is the combination of both of them, the location and orientation at the same time. And here's the illustration of the environment, and the episode length gonna be in the 300 steps. And then agent. In this slide, we delve into our agents powered by the Modular Physics engine with Octa Humanoid. Their design is critical as it directly impacts their interaction within our simulation box. The agent's observation space is tailored to include wide range of sensory inputs. This isn't just limited to their position or velocity, but also their orientation in relation to the box they're tasked with manipulating. It's all about giving them a rich perception of their environment. Action space are consists of the joints of the humanoid to learn how to walk and pushing the box. We throw in an element of unpredictability by introducing randomness to their starting position. This means they need to be adaptive, learning robust strategies to handle a spectrum of scenarios. It's this ability to recover from diverse starting conditions that test and prove their resilience and adaptability. And this is the reward function. The reward function can be categorized as individual rewards and objective rewards. Individual rewards is how the agent moves towards the box, and objective rewards are of how the box moves. Firstly, the target location scenario, the total reward combines individual reward with reward for reducing the distance to their target, which is R distance, and the completed efficiency is R efficiency, and indicator of tolerance of minimum distance. And target rotation only, adding the reward for rotational, efficiency, and the third is combination of both of them. This is the individual reward of how the agent moves toward the box. In individual reward, there are R progress, which is the progress of the agent moving closer to the box. Reward alive and reward upright. Also, reward heading ensure the agent maintains a viable posture to alignment towards the box, because we want our agent not to just move, but to move correctly and purposely. The reward action and reward effort components are about finesse. They penalize excessive actions and encourage the use of just the right amount of force. It's like teaching our agents the art of elegance in motion. Now, potential here refers to the positional potential of the agent relative to the box. Incentivize the reduction of distance between the agent and the box. Okay, and this is the objective reward function, which is categorized by reward distance, rotational, and efficiency. Reward distance is where delta dt measure the reduction in distance between the box and its target, achieved by the agent's effort. As illustrated in here, delta dt is the reduction of the distance at each one time step. And then the rotational reward is delta dr, quantifying the improvement in orientation from one time step to the next. And efficiency reward is how fast the agent could complete the task, which means the faster it is, the bigger the reward it could achieve. Okay. And here is the proposed method that we are gonna do. In the real world, each agent cannot know what the other agent thinks or what they see. So in here we propose the communication. Other part we have the message aggregator, a pivotal feature that allows for the synthesis of message for multi-agent. During training, agent encode their state and action into a message, which will be shared to the other agent. As we can see, this is the policy gonna generate an action message for the other agent, and the state is gonna pull the CNN. And from the message aggregator here, the information from the other agent gonna be used as the critic. Okay. Now we're gonna explain the thing. Usually in state representation is using 1D state vector. So since we gonna use CNN to capture the spatial feature After that, it goes through the CNN to capture the spatial feature of the state, and then encode it as the state representative. Also, we can call it as MT. In this way, the agent can learn by communicating each other. The action message here is gonna be like negotiating between the other agents. They maybe give comment or receiving comment to achieve the bigger reward. Here's the result of the first. In here, the experiment is run from five runs, and the light color represents the mean of the running, and the shaded background is the standard deviation of the 5 experiments. In here, we can see that IPPO with communication have high reward, although have many deviation, and can improve the IPPO with the centralized. And here is the video of the IPPO. And in IPPO post communication, the agent trying to move the box together at the same time, while IPPO didn't consider the other agent, so he just trying to push by himself. And MIPPO is trying to push together. And the second one is computationally. In here, the MIPPO, the centralized one, still overwhelm the other method. But you can see by adding the communication, you can improve the centralized learning. Oh, the blue box is the object and the green one is the target position. In this scenario, it doesn't consider the position, so only just rotation of the box. And the third one is combination of two. In here, we can see as the same as the second one. The IPPO with communication can improve better than the IPPO, and it can achieve small standard deviation with high reward. And here is the result. In this case, the reward for the distance is not high enough, so that's why it only tries to rotate. And before it can achieve the position, it stopped because of the episode length only 300. And the result is here. The maximum minute cumulative training reward occurs over 5 runs. The number in the parenthesis is the step which is achieved the highest. In here, the with communication achieved highest in the first scenario. For the second one, MFTPO still achieved the highest, and adding the communication still better than the centralized one. Also, same with the third scenario. The conclusion is, while our communication centric approach for the centralized learning has not surpassed the performance benchmark set by centralized method, it has significantly enhanced the capability of the centralized multi-agent system. The strategic exchange of information between agents has yielded notable improvement, underscoring the potential of improvement communication protocols, evaluate multi-agent coordination and performance in complex tasks. For future work, we will explore agent leadership by varying communication styles. Here's the reference. Thank you.
Okay, thank you. Any questions from the floor? So if no question from the floor, may I navigate you to the proposed method page? That's one. I'm so curious, what kind of CNF
2D.
2D CMM.
Yeah.
And then what is the output of this 2D CMM?
2D is kind of like spec representation, kind of like encoder.
Yeah, I
reduce
know.
the-
Yeah, because now you get the output of the CNN is like MATY, this one, and then you try to get all message together. I'm wondering what is output? This output is what matrix or what?
No, it's just what the agent learned. He trying to not sorry. What the first agency is trying to tell the other agent. But since the state is too big, so we're trying to reduce to only have five. Kind of like in here. In here, the observation is 100 and 130K. And since it's too big to give information to
So
the
you
other
may
agent,
use this 2D CNN as a feature extraction.
extraction and reduce the.
Okay. And how to aggregate this message? This one you just summarize all together and then
Yeah, this
aggregate.
something.
Okay, got it. Then would you please go to the result page? I mean, and now you have like a simulation, like yeah. Take this one as an example. Would you please try to interpret it? Because it's quite difficult for me to tell the difference between this and this.
I'm still not sure how to get the correct method to know the coordination. But as from the visual only, the first one is they trying to push together at the same time for IPPO and communication. The IPPO only, since the agent don't know there are another people, so he just try to push himself. So that's why in IPPO mostly the agent pushing himself while the others still not arrive in there.
Okay. Okay. Thank you. Any questions? Okay, no question. Thank you for your presentation. And yeah, it's about time to end today's session.